Okay, 12b, area between curves, example 10. This one's a little bit tricky because it's doing the trig curves. We'll find the area of the shaded region. Again, with something like this, split it up, area 1, area 2. Oh, can't really read that there. We need the point of intersection. So we know that they intersect over here on pi on 2. We need this point here. So where do they intersect? Obviously, if you've got your graphic calculator, you're going to G-solve for intersect, which is fine. Without the graphic calculator, we've got cos x equals sine 2x. So we need to use some trig. Sine 2x is 2 sine x cos x. So if I go with, bring the cos over, 2 sine x cos x minus cos x, and I then factorise and take the cos x outside, 2 sine x minus 1. We then get that cos x equals 0, or if I've got 2 sine x minus 1 equals 0, sine x will equal a half. This will give me cos x, this will give me x equals pi on 2 as a solution, which we know pi on 2 is one of our solutions from the graph they gave us. Or sine x equals a half, therefore x equals pi on 6. Remember our 60, 30, 1, 2, sine, yep, 30 degrees. If we were doing this tech free. As I said, if we were doing this tech active, you can do it off G-solve and just intersect. So then we need to work out area 1 is our first area. So that's from 0 to pi on 6. The top curve there is cos x, and the bottom curve is sine 2x. Area 2, which is from pi on 6 to pi on 12, the top curve is sine 2x minus the bottom curve is cos x. So that's the important thing when you're doing your area between curves, is that when you set it up, you're doing the top curve, subtract the bottom curve. Now it's just an integration. Cos x goes to sine x, minus, this will then become negative a half cos 2x from 0 to pi on 6. So that's sine pi on 6, oops, excuse me, plus a half cos pi on 3. Take sine 0 plus a half cos 0. Sine of pi on 6 is a half. Cos of pi on 3 is also a half, so a half times a half, minus sine of 0 is, sine of 0 is 1. Take, sine of 0 is 0, isn't it? Apologies for that, that was a silly error. And then cos of 0 is 1, so that's going to be take a half. So I've got a half plus a quarter plus a half. So therefore I get an area of, just checking I haven't made a mistake with my negatives, so 1 1/4. Now area 2 is from pi on 6. Let's do this one on our graphic calculator, just to go with this. So let me go there. I want sine brackets 2x, take cos x from pi on 6 to pi on 2. I should always just oops, excuse me. I just need to double check my setup. Yes, I am in radians, so that's all good. Execute, that's a quarter. I believe I may have made an error over here too. Let's try this one. Let's try calculate. So let's do this one. Cos x minus sine 2x 0 shift pi on 6, and that should be a quarter. I did make an error with my negative, didn't I? Oh, silly error here. This should have been a plus. So this should have been a take. This should have been a quarter. So it's very easy to make mistakes with those negatives. I'm actually going to leave that in my video so it's more realistic for you. So obviously now total area is a quarter plus a quarter is a half units squared. Okay, there we go, everybody.